Welcome back, viewers. In this case, you'll be told to integrate from 0 to 2 of negative 3 raised to power x with respect to x. Now remember, from the laws of indices, when you have ab raised to power x, that is the same as a raised to power x times b raised to power x. So if you are given negative 3 raised to power x, that will be the same as negative 3 is the same as negative 1 times 3 raised to power x. So if our a is negative 1 and b is 3, then it means we'll have a raised to power x, b raised to power x. Meaning that will be negative 1 raised to power x, then times 3 raised to power x. Again, when you go back to the exponential function, if you have exponential natural log of x, exponential natural log of x is just x. Then if you have ln of x raised to power a, then that is a ln of x. So what is the implication? The implication is that when we now take this 3 raised to power x, it is the same as exponential ln of 3 raised to power x. Then the x becomes the coefficient according to that law. That means it is the same as exponential x ln of 3. So that is the first case. You go back again. When you have the Euler's equation is exponential I theta to be equals to cos theta plus I sine theta. So when theta is pi, then where this theta we substitute with pi, we are going to get exponential I pi to be equals to cos pi plus I sine pi. So if you do that substitution, cos pi from the calculator, if you work out cos pi, you get cos pi is negative 1. Then it is plus I. Then if you substitute the value of sine pi is 0. Sine pi is like sine 180 degrees. Cos pi radians is 180 degrees. So I times 0 is 0 plus negative 1. You will get the answer to be negative 1. So what do we have here? We found negative 1 is the same as exponential I pi. That is exponential I pi. So if we raise both sides of the equation to power x, if you raise both sides of the equation to power x, what will you have? You will have negative 1 raised to power x is equals to exponential I pi times x is I pi x. So we found the second equation. Now we have that negative 3 raised to power x, we found it is negative 1 raised to power x times 3 raised to power x. And negative 1 raised to power x, we found is the same as exponential. This one we found is equals to exponential I pi x. So if you substitute there, you get exponential I pi x, then 3 raised to power x. We found 3 raised to power x here to be exponential x ln of 3. So it is times exponential x ln of 3. So again, the laws of indices, if you have the same base with multiplication sign, you add the powers. So we'll have negative 3 raised to power x will be exponential is the same base, it will be e with multiplication sign, you now add the powers, that is exponential I pi x, then plus x ln of 3. Now here, x is a common factor. We can factorize out a common factor. That will be equals to exponential x into I pi plus ln of 3. So we've now found negative 3 raised to power x to be exponential x into I pi plus ln of 3. Now this I pi plus ln of 3 is a constant. So if we let that constant to be a, meaning if we let a to be equals to the constant there, I pi plus ln of 3, then what will we have? We'll have negative 3 raised to power x to be equals to exponential I pi plus ln of 3 is a, so it is x times a. That will be exponential ax. So if we go back to our problem, you were told to integrate from 0 to 2 of negative 3 raised to power x with respect to x. That will be what? That will be the same as integral from 0 to 2. Negative 3 raised to power x we found is ax. So we substitute it with this value which is exponential ax dx. So if you integrate exponential ax dx, remember integrating an exponential function when the derivative of the inner function is a constant. If you differentiate ax, you get a constant a. Then that is automatic algebraic substitution. The exponential function remains the way it is, then you divide by that constant of inner function. Then you put the limits of integration is from 0 to 2. So when you substitute, when x is 2, you'll get exponential 2a over a. You substitute the upper limit, then minus. When x is 0, you'll have exponential 0 over a, because 0 times a is 0. So what do we have there? So we found the integral from 0 to 2 of negative 3 raised to power x with respect to x is what? It is exponential 2a minus exponential 0 over a. Remember, a here is like a common denominator. If you simplify that, you get a is the common denominator, then it is exponential 2a minus exponential 0. Now, this will be what? Anything raised to power 0 is 1. So we have exponential 2a minus 1 over a. Then you go back. Remember, what was our value of a? If you go back, you see we let a to be I pi plus ln of 3. Remember, a was equals to I pi plus ln of 3. So if we substitute back, we find that the integral from 0 to 2 of negative 3 raised to power x dx, which we found to be exponential 2a minus 1 over a, if we substitute back the value of a, what do we get? Where there is a, we put the value of a, that is going to be exponential 2 into the value of a, which is I pi plus ln of 3, then the value of that is minus 1, then over a. A is I pi plus ln of 3. Now, what do we have? 2, when you take 2 inside the bracket, we have exponential 2 pi I plus 2 ln of 3, then minus 1 over I pi plus ln of 3. Now look at this case. Exponential 2 pi I plus 2 ln of 3. That means when you use the laws of indices, you get that is exponential 2 pi I times exponential 2 ln of 3. Because when you have the same base with multiplication sign, you add the powers. Then the whole of that is minus 1 over I pi plus ln of 3. Now, look at this first case here. So we found, of course, this is the integral from 0 to 2 of negative 3 raised to power x dx. Now, if you have exponential 2 pi I from Euler's equation, exponential 2 pi I will be cos 2 pi plus I sine 2 pi. When you have theta is 2 pi, where this theta you put 2 pi, you'll get this. So what do you have here? Cos 2 pi is 2 pi radians is 360 degrees. So cos 360 is 1. So cos 2 pi is 1. Then it is plus I sine 2 pi is 0. So 1 plus 0 is 1. Meaning exponential 2 pi I is 1. Then again, exponential 2 ln of 3. This part, exponential 2 ln of 3 is the same as exponential ln of 3 squared. This coefficient becomes the power. So exponential ln of 3 squared, That is exponential ln of 9. And exponential ln of 9 is just 9. So when you go back to the solution of your problem there, the integral from 0 to 2 of negative 3 raised to power x dx is going to be what? Exponential 2 pi I, and exponential 2 pi I we found is 1. Then it is times. Then it is times exponential 2 ln of 3. Exponential 2 ln of 3 we found is 9. So it is times 9. Then minus 1 over I pi plus ln of 3. Now what do we have here? 1 times 9 is 9 minus 1 over I pi plus ln of 3, which will be the same as 9 minus 1 is 8 over I pi plus ln of 3. Ladies and gentlemen, that is how to integrate that given problem. Thank you for watching, and see you again in our next lesson.